Thank you. Thank you. So everyone, so I'm Luca Schiatti. Today we are talking about AI agent and in particular how we build ecosystem of AI agent and what are the building blocks that we need to consider if we want to go to the next generation of AI agent. I'm Luca Schiatti. Does it work anymore already? Okay, sorry. I'm Luca Schiatti. I'm part of Accenture. I work several years in the applied research group of Accenture, and recently I moved on data and AI, working mainly in the last year on distributed ledger, distributed identity, and confidential computing. And some of the topics I will touch today are connected to that. So we know that AI agents are becoming more and more spread everywhere. We interact with agent via chatbot, but not only the agent are going to be part of IT architecture, they will need to be connected to legacy system, they will need to connect to people, and we can see in the future that agent can then connect it between them, not only agent on the same entity, but also between different entities. So we believe that to be able to achieve that, we need to work on three layers: the identity layer, the privacy and traceability layer, to be enabled this what we call verifiable AI agent. So these are the topics that I'm going to cover a bit today. So why we need that? So we talk a lot about autonomous agent, but autonomous doesn't mean accountable. What we need is that when we have agent, we need to know who these agents are, what they can do, and we need also to be able to track which data they are using and the decision that are taken. Also, we have a problem of data privacy. We'll give more details on this. But of course, this agent will get access to legacy data, personal data, and more powerful we want to have the agent, more access to data they need to have. So we need to make sure that data stay private end to end. And finally, of course, we want to be able to be compliant and follow all the regulatory that we need that are in place. So this is a bit the challenge, and what we believe is that to solve this challenge, we need to focus on these three different aspects that I mentioned before. So first, we need to have a verifiable identity. So we need to give to every agent a unique identity. We need to know who create them, what they are responsible for, and what they are allowed to do. Also, on top of that, we want to make sure that we have data and code protection in use. I will give more details on what does it mean, how we solve this problem with confidential computing, but we want to make sure that even when our data are processed by this agent, by foundation model, we want to make sure that our prompt, our data that we get via RAG system or with MPC are protected at any stage. And finally, we want to make sure that we have code integrity and data lineage. So what I'm going to do today in this presentation is to go one by one, give a bit more details on how we see we can achieve that, and then how we can build this ecosystem of agent by leveraging this technology. So first, let's start with identity. What does it mean, identity for agent? As I mentioned, we need to imagine a future where agents are not only in the same entity. We can imagine an ecosystem of agents where when at certain point, agent can access to other services that are provided by third-party agent. These agents are interacting with user. They are getting data from the user. They are getting data from the legacy system. So we need to imagine this ecosystem of different agents. And the main point of agent is that differently from what we are used, they are not deterministic. So we know that LLM are based on probabilistic model. So we don't know exactly which decision they're going to take, which service they're going to contact, etc. So the more autonomous we want to have this system, more the complexity increase. So we believe that there are some requirements for the agent to be able to achieve that. And the first one is about unique identity. A bit as we have identity for people, the idea is that also this agent will have an identity and an identity that can be proved and verifiable. They will mean to authenticate between themselves and then they will have to need contextual access. So at certain point, we need to have either just-in-time access or long-term access to external resources. And finally, we want them to be observable. We want to maintain the logs on what they're doing, which data are using, and we want to be able to do auditability on the agent. So to solve some of this problem, we need to give this unique identity to the agent. There are several initiatives on this. We are seeing an extension on OpenID standard for agent, but one thing that we are looking at in Accenture is how we can build, connect the concept of decentralized identity to autonomous agent. I don't know if you are aware a bit about what are DID, what is decentralized identity, but the idea is to take some of this concept that applies for human identity and to apply them to agent. So just to give a bit overview on how this works, we can imagine that we have an agent that has the classic private and public key, and then with this agent is assigned a DID, a unique identifier. And then we can, with an identifier resolver, connect the DID and verify the identity of the agent by, for example, doing challenge and making a signature to verify that is actually the owner of that DID. And then as this agent has this DID, we can imagine that all the agent in the ecosystem has a DID. And all these DID can be verified in this data registry that can be centralized, decentralized. We can imagine different solutions for that. And then in the context of verifiable credential, once we have this unique identity, we can imagine that every agent has an identity wallet. And in this identity wallet, we can issue what we call verifiable credential. So these are exactly the same concept of decentralized identity, but applied to agent. So any agent or any other entity, even a people, etc., or institution, then can issue a verifiable credential. A verifiable credential is a signed message that contains information that can be verified. The classic example with human is my credential could be my driving license, and then I can send my driving license signed with my key, and then with the registry we can verify the identity, and we can verify that this driving license is actually signed by an entity that has the power to sign this type of credential. And the same we can apply to agent. In this case, for agent, we can imagine that first we have the identity on who created them, so which is the entity that created this agent, what this agent can do, and other certification of the agent or delegation. For example, we can say that this agent can have access to certain information, can have access to some personal data, etc. So we can imagine different credential to be able to empower the agent to take some action and access to other agent or any data. And then in the concept of decentralized identity, when we issue an agent, so we sign this credential, we send it to the agent, to the holder of the credential, and then when we present this credential, a verifier can check, as I mentioned before, that the credential is valid, and then it can take action based on that. So this is a basic way we can see to apply to agent, and then once we have that, we can then build an ecosystem of agent where agent can authenticate between themselves, they can verify that they are legit, and then if needed, according to the credential that they have, they can eventually, like in this case, agent A can ask agent B to get access to certain data from third-party data or internal data. So, and these are only two, and then we can imagine many agents that are interacting and talking between them and share information according to the context they are applied. And from there, what we are missing is a certain standardization. So here is a bit how we can define the identity of the agent. Now, how we can improve this by applying also existing protocol for agent communication. So this is not related to identity, is a protocol for standardization and interoperability of agent that is developed by Google. Is a proposition that someone starting to adopt, and is a way to standardize the way we represent the agent. So there is the concept of agent card, and this agent card contains the information on what this agent can do, what are the endpoints to connect to the agent, what are the authentication requirements, etc. Then we can see the task that the agent can do and the example of prompt to interact with this agent. So this is a protocol by Google, and we have early adoption of this protocol. And this allows to have the concept of this ecosystem of agent, because then this card can be published, and then you can search in the cards to see which agent you have and what you can do. And you can imagine that LLM could even discover themselves which agent they need, and then go on the agent card, evaluate the agent card, and then connect to the agent all autonomously. So this is a bit the concept of this protocol. And if you apply this protocol with identity, now we have the next step. Not only we have the identity of the agent, but from there we can start to build credential based on agent's card. So I can access to the agent card. I can verify that is legit. I can verify that the endpoint are legit, and then I can connect to the agent and start my agent ecosystem. So this is the first building block I mentioned. So we start from agents that are today difficult to identify. So normally in the current experimentation and current pilot, we don't have ecosystem of agents. Normally are run all by the same entity, but by building this identity concept, connecting with standard protocol for agent-to-agent communication, we can then have this next step of agent ecosystem, where we can even imagine that these two agents are run by two different complete entity. So when I say entity, I mean one could be run by Google, the other by Booking, etc. And then we can interact this with chatbot. So we have this, we can build this first ecosystem of agent. Now, if we imagine that this is possible, we have an issue about data privacy. We want to make sure that if an agent A needs to speak to agent B, and they need to exchange some data, if they need to keep the context of all the flow orchestration of the agent, we imagine that there is an exchange of information, maybe an exchange of personal data or data that we want to keep confidential. So maybe I need a service from an agent, but I'm not sure I want to use it because I don't want to share my personal information with this agent. And this is where confidential computing can play a role on the data privacy aspect. I mean, the problem, it's easy to imagine, so this is a famous meme, but the idea is that today we are giving a lot of information to foundation model. We are writing, asking stuff, and if you take my ChatGPT history, you can probably start to profile me, understand many things about myself. So there is already, the way we are using today foundation model, a big problem of privacy. And even, of course, in the enterprise context, we have foundation model deployed for the context itself, but still, every time the LLM process our prompt, process our data, our enriched prompt with external data that we retrieved via RAG system, we have a problem that these data are visible by the owner of the foundation model. So what we can do to solve this problem, we can apply the privacy enhancing technologies to LLM, to foundation model. So for example, this is just the theory of privacy enhancing technology. Today, of course, we know that when our data are at rest in our devices or on the cloud, they're always encrypted. We know that when we transfer data, the data are always encrypted. But when we use the data, when we process the data, we need to decrypt them. We need to have access to this data. And privacy enhancing technology are emerging techniques, I mean, since already some years now, that allow to keep also the encryption while the data are in use. There are several techniques to do that. Some are less mature, some are more mature. some are software-based, some are hardware-based, but we are seeing a set of new technology that allow to keep the data protected in use. The classic the theory example behind this logic is that, if, for example, if you want to know between us who is the wealthiest, we need to share, every one of us need to share our net worth, and then we need to compute. So to compute who is the wealthiest, we need to see the net worth of each of us. With this technology, we can do this computation by guaranteeing the privacy of each single data point and get only the output. So this is a bit the high-level idea of this technology. So we can imagine that we can apply this technology to AI. One of the most mature solutions that allow to do this is what we call confidential computing or trusted execution environment. These are hardware-based, and these today are already available in any cloud provider. They are based on the chip manufacturer that are creating chips that implement a trusted execution environment. So what is and we have the concept, for example, in Azure, in every cloud, the concept of confidential VM. The idea of this technology is that thanks to the hardware, we can guarantee that whatever happens in this confidential virtual machine is private, is not visible externally. Even by the cloud provider, everything is protected. If we take a dump of the memory of the virtual machine, we are not able to see anything. And then there is all a certification system that allow me to verify before to share the data with this confidential machine that we are actually running inside a trusted execution environment. So this technology is real today. And then from there, I mentioned chip manufacturers, so Intel, AMD, they are providing this type of solution, and even NVIDIA, with the latest GPU, they are providing this solution. So even the GPU, and this is important for the AI processing, has this confident, trusted execution environment. So now, starting from there, we can imagine a different way to deploy our foundation model. We can imagine the most basic example and to protect our query and response. So if we take our foundation model, and there are already some companies that are proposing ChatGPT-like services, but completely in confidential computing, I can deploy my foundation model inside a confidential computing, and I can guarantee with attestation service, etc., that my query and my response are completely private. So I send my query, the LLM is able to run the LLM on my prompt, but is not able to see what is processing. And I can get my response encrypted that I can uncrypt on my side. So this is solve the problem I mentioned before. And then from there we can imagine more advanced scenario where we can even do fine-tuning model with our data, and keep the fine-tuning, the data used for fine-tuning private, end-to-end, and even most advanced, I can imagine that I can ship my model, my IP, somewhere in a third-party system, and guarantee that the one where I ship it, the one that are using my model, deploying my model, are not able to see even the code, and we can guarantee IP protection. So these are some aspects where this technology can work with the LLM, AI, and confidential computing. So starting from there, we can imagine then to build AI agent that use foundation model in a trusted execution environment. So we can imagine that our data are running a trusted execution environment or not, depends. If we have some vector search, maybe we want also to protect that part. But the main important thing is that we can run our AI agent inside this confidential computing. And then when this agent connect with the LLM, also the LLM that could be, again, deployed by the same entity or even a third-party service that provide this LLM in a third-party environment, it can be also protected with a trusted execution environment. Of course, we need to guarantee every time we interact between this layer that every aspect, every layer every time we connect between different layers, we need to make sure that we have this certification system and check if the trusted execution environment is actually there when we interact with these services. So this is an example that we developed. It's a simple RAG with a long chain agent. Of course, this is really basic. There is only one agent, so there is not really a group of agents. But the idea here is just to say that we can imagine that I'm prompting via UI with a client, a chatbot client that is running on this trust execution environment, is connecting to the long chain agent, is verifying, are you running on a trust execution environment? If yes, I can send you my prompt. And then the agent also will do the same when connecting to either external data source, like in this case, to connect to knowledge graph, or when it connects to the LLM. So here we guarantee privacy end-to-end. And the data that are exposed by Neo4j are kept private for the long chain. The agent, the LLM doesn't know what is the prompt of the agent, and even the agent doesn't know the prompt. So every building block is blind on the data that is processing. Of course, this is the extreme. We can imagine different cases when sometimes I need to see the data, sometimes not. So it really depends on the need, on the privacy requirement of your system. So then from there, we have the identity, we have the protocols that I mentioned before, and now we can add this trust execution environment. So if we go back to what we see before, we have the agent that is own identity. It can connect with another agent, it verify the credential to make sure it can be trusted and it can be verified. And then we can also guarantee with the trust execution environment that if the agent A is connecting to agent B and are exchange data to implement the flow that they need to implement, the data that we are exchange, if needed, are kept private and encrypted. And this add this additional layer to our agent ecosystem. Of course, as I mentioned before, we need to make sure that we have this trusted authority that is connected to confidential computing to actually verify that I'm running in a trusted execution environment. So we have an issue with this way to see things. The issue is that, okay, I can trust that you are running in a secure environment, but how I trust the code that you are running in this trusted execution environment? Because the trusted execution environment guarantee that the machine, when I'm running my process, my agent, is protected, but it doesn't guarantee me that if you send me your personal data, my code are not doing something malicious and is exposing my data outside. Because of course this is a VM, is a confidential VM, but the code that I decide to deploy in the VM is not checked when I check if you are running on a trusted execution environment. So to solve this problem, we have the last part that we need to add to this picture is about code integrity and data interaction lineage. There are emerging solutions for this, but the idea is that here I want to make sure that my AI supply chain is compliant with the company policy and regulation, and I want to produce proof of what I'm doing in this with this AI supply chain. And by combining this with confidential computing, we can create cryptographic proof signed about all the inputs, the output of my AI, what I'm running, what is the code that I'm running on both CPU and GPU. The idea is this high level that we have this digital notary service that is implemented inside trust execution environment, and then it keeps providing this proof to guarantee the code integrity and the data lineage. When we say code integrity, it means that we can guarantee that the code that is running inside trust execution environment is the one that I'm expecting that is running. Of course, here there are some complexity because we can imagine that this code needs to be, of course, validated by someone, and if it's if we need to protect the IP, we need to have a third party that, of course, verify that the code is correct. But once I have that, I can guarantee every time I connect to the TE, I verify that you are running on a trusted execution environment, but I also want to verify that the code that you are running is what I'm expecting, and there is no data leakage from the code. And as soon as something changes, I can verify that, I can check that something is not as expected, and I can stop any communication with this agent. And then, of course, the other aspect, this is for code integrity, and then this digital notary can also guarantee interaction lineage, data lineage, etc. So we can, in the same way, start to track which data are getting, which data are using, what are the decisions that is taking, and then have a full auditability of my agent and what is doing. And again, this is connected to confidential computing. It's possible thanks to confidential computing. And then if we add the identity in the loop, we can have this full verifiable AI system, the full verifiable AI identity that guarantee privacy, integrity, and lineage. So as you can expect now, it's the same as we saw before. We add this layer of data interaction lineage. And just to recap, now we can imagine agent A connecting to agent B. First, I verify your identity, because maybe I found you via this agent card for HOA protocol. I first verify your identity. I can verify your credential to check what you can access and what you can't access, what you can do and what you can't do. And after that, I can verify that you are running on a trusted execution environment to guarantee data privacy. And I can verify data interaction lineage to make sure that what are you claiming you are doing is actually what you do, and there is no something suspect happening in this agent. So again, and this, of course, all these checks can be automatized, and the idea is that with this element, we can finally, if we bring them all together, we can finally build this ecosystem of agents where we can discover them and guarantee the full traceability of what is happening in my AI supply chain. And that's why we call verifiable AI. So this is a bit the idea, what we are looking for. Of course, this is conceptual for the moment. The proposition for the distributed identity is one. We could imagine different standards. What is more mature in this case is the trust execution environment, because this is something that is already running, and we experimented with some of our clients the AI agent in this confidential environment. And then there are emerging startups that are working on this aspect of digital notary interaction lineage. So some of these elements are already ready today. Some will be developed. And of course, the main challenge on this, as any type of ecosystem that we saw in the past, is to be able to standardize, build a protocol that are recognized by all the players in the system. So this is, of course, the most difficult challenge to make this possible and achievable. But this, I think, a bit the idea on what we need to go, where we need to go to be able to build this AI agentic ecosystem. And that's a bit all on my side. Thank you. Yes. So I need to read that. Yeah, for the first question, the way you design your agent, so this is up to you. I mean, ideally, we want to restrict more as possible what an agent can do. So what we are seeing in the first architecture that we are implementing is that every agent is a small capability, but of course this is up how you want to implement. And then for the user identity, we have different aspects. If we implement this distributed identity, but unfortunately is not the case for human, is not still developed, we can imagine that this identity can connect with the agent identity in the same way. So they're using the same protocol to do that. If not, of course, the agent need to integrate the current identity system. I don't know if I answer the question, but this is what I understood from the question. I take the second one. So from what I see is that we are seeing the first agents deployed in the real world. But as I mentioned, for the moment, these are agents that are doing simple things. So in the sense that the things that we saw in the presentation of this ecosystem of agents that are connecting between them, between entity, for the moment something that is not real yet. So this is more the next step. What we are seeing, the first, a lot of experimentation, of course, with the AI agent, and the first agent deployed in production, but with the limited scope based on the LLM, on the task they need to do. The main challenge of making this real is that, as I mentioned in the beginning, is that these agents are not always predictable. So we experiment this when we use everyday AI. The answer that we get sometimes are wrong, sometimes are not exactly what we are expecting. Maybe the prompt is not well done. So there is also an issue in testing this agent, in being able to make sure that the agent are not doing something that we are not expecting to do, because since the output is not deterministic, when you put this in production, and there are some famous cases on a chatbot that did a strange answer, and they start to sell to confirm that you can buy something at €1 when the price was much more. So there was some attack via prompt, and then you have the same problem when you deploy agents. So we are seeing some first deployment, but it's still at early stage in the production environment. Also because this is something that I think agent 1 year ago, even not 1 year ago, we had agents. So it's something that is emerging really, really recently. So the next question. So that's what I was saying. I would not say there are research, the part of decentralized identity, so it's something that is out from a while. The main issue of this technology is, as I mentioned, to create the standardization. So in terms of maturity of the technology, I think we are there. What we are missing is the standardization. That's why, for example, Google started this HOA protocol, is to start to build some standardization on top of how we manage agent, etc. But there is a lot of work to be done there. But it's not a research topic. So the technology for identity is well established, and the technology is available today. So on the question on data security on a smaller scale, as I mentioned before, the confidential computing technology that I present, that I explained quickly, is something already available today in any cloud platform. So even as a startup, if you're using any cloud, it's something that you can easily access. In Azure today, you have also GPU that can run this confidential computing. And not only, there are some company that are providing this service as a third as is provided by OpenAI. So you can buy token, and then you can start to query this foundation model with all the data security guarantee. I'm looking the next one to take. Yeah. The other is really important. The last question, as I mentioned, there is OpenID that is starting to add in his protocol some agent aspect. But the idea is that if, and that we believe we will do, the agent will become more and more common, we will need to have them standardized with the way we standardize everything else today. And then the last question. Okay, this is the one I answered. I don't know if there was any other question. If not, that's all for me. Thank you.